Welcome to Barefoot from MySQL to Cassandra and back. This is a talk about the growing pains of having gone from an RDBMS to Cassandra, and the same growing pains on if I'm coming back. Let me go over a little bit about me. I'm a certified MySQL DBA. I like to say I'm one of the last certified MySQL DBAs because a lot of those certifications got retired and they're not coming back. I'm an open source enthusiast, and apparently I've also been inflicted by a mummy's curse because I've been noticing in recent years that every time I submit a talk to a conference and it gets accepted, my company basically downsizes a few weeks later. So even though my biography says Tivo, I'm actually not there anymore. And because I don't like to waste people's time, I'm going to make an assumption about you. I'm assuming that you're a certifiable MySQL DBA, and if you've actually been working with MySQL long enough, you probably are very certifiable in that sense of the word. You probably got asked by people at work or people you know, make our databases faster. What they actually really meant was they want you to scale up their writes, and because there's like 1,000,001 ways to scale your reads. And I'm just going to say, okay, you're all poor schlubs if that's happened, who just happen to need faster write performance. No, but really you're someone who's more familiar with a relational database system, and you're actually getting a little bit curious about NoSQL. I'm going to guess that you're also here because you're considering switching to Cassandra or NoSQL solution. I'm going to ask in general, well, why do you want to switch if that's the route you are going? All right, no takers. All right, and I'm going to guess that when you were trying to scale out your writes, you've already tried everything possible, from switching to SSDs to partitioning your tables to separating bin logs to another block device. Actually, that's a pretty rare one. Does anyone ever try to improve their performance by having their bin logs write to a completely different disk? Yeah. And making sure that, and I've also torn my hair out to go through slow log, to tweak the slow logs, look through everything to make sure that all procedural statements were properly indexed, and that in that index buffer pool has always been large enough to hold them. But still, sometimes your company scales out their writes so fast that you still need to act. All these strategies that you've tried still aren't enough. Well, I'm going to actually talk about a couple of disastrous strategies. Well, this isn't actually a very disastrous one. This is actually the default strategy that most people go with. It's just regular active master. One of them goes to a slave pool, and if you're fortunate enough to be using global transaction IDs, then every time one of your masters goes down, then you can have the slave pool say, I want to switch over. Or if you're actually unfortunate enough, like I was, you'll probably have a script that basically scans through the bin logs of the other master to try to figure out where to resume. But some companies basically make the rather disastrous decision to say, well, why don't we try to speed up our writes by writing to both masters? Well, for one thing, you get a split. You sometimes get a split brain decision here. Like if you say update table, set value equals a, where such and such value, and the other master receives exactly the same statement except for a different value. How do you know which value it's actually going to be? And unfortunately, I'm also going to add that master is is only scalable by a factor of 1x. Well, you're going to maybe double that. But even then, in practice, that's not the case, because you're still going to come down to just one execution thread for all incoming statements. So if basically both masters are fully loaded and their bin log entries are basically going into the slave pool, everything's going into one single thread. This is actually a little bit disastrous. I've actually had companies that say, well, we actually have a data center in various parts of the world. Since a master is already like a ring topology, why can't we just have a big ring around the world and copy and replicate only the data we want? Well, aside from the fact that you screw up one connection and replication is completely horked for everything downstream of that. I also like to point out that also the problem with this model is that the data center that's off the coast of Greenland usually sinks and gets flooded. Okay, that was a joke. And with more recent versions of MySQL or MariaDB, you've now got introduced a true multi-master topology. You can actually set a different replication channel for every master that you're replicating from. The only thing you have to watch out for is that you're not going to replicate conflicting data. But once again, we get the same problem here that if this is an intermediate master that's going to replicate to other slaves, everything is still coming into a single replication thread. You actually haven't scaled up your writes in this particular model. Oops. This one I've seen at a lot of companies. This is workable. This is basically where you have a sharding API, and each shard goes to a master. If one of the masters dies, then it simply just fails over to the other one, and the DBA gets a call to replace the other master. This one is scalable, but you generally have to work with your engineers a lot in order to get this, in order to start adding new shards to this. Oh, did I see a hand? Okay. Oops. However, we start to get a little bit closer to true scaling true scaling of writes with Galera. I mean, Galera is not a known SQL solution yet. I'll get there in just a moment. And I often like to joke that once all I've simply done was just, whoops, why is this not going back? All I've simply done for that diagram is just take my 5 points from the world ring and stuck it in more what I call a ritual diagram here. I don't know what I'm actually going to summon once I actually set up Galera, but okay, that's another joke. Except that with Galera, the interesting thing about Galera is that every single node still carries a copy of all the data. Whenever you write to one node, that data is basically going to get replicated to all the other nodes through a form of row writing. Well, they call it certificate-based replication, but one of the things that also makes it so fast is there's actually no bin logs to the Galera model. This is actually scalable, but I still find it a little harder to configure until we get to the actual Cassandra topology. I have the arrows a little bit wrong here. The arrows should actually be going in both directions. Now, what makes the Cassandra... I haven't even gone into what makes NoSQL yet. I'm just simply talking about the topologies of the different database types that made me actually eventually consider Cassandra. Cassandra still works in a ring. Oddly enough, not all the members of the ring have to be in the same data center. Some of them can actually live outside of the data center. Some of them can live within a data center. It will still function as a ring that goes to here and there and back again. However, in the Cassandra topology, unlike the Galera topology we saw earlier, only shards of your data lives on each given node. Some of these, the moment you write to a node, it's basically going to copy that shard to a certain number of other nodes. You can also control how much of that writing occurs generally within the same data center itself. and which parts of it are verified against the same data center or verified to outside the data center. I tended to go with Cassandra because of, for the reasons listed. It's highly available, and for those who aren't familiar with HA, I'd like to just say all that simply means is that you can take a shotgun to any one machine or a certain number of machines, and the entire thing will still function. It's amazing how many clients I come across these days who still have not heard of HA and just say, I want somebody to be able to wake up in the middle of the night, rush down to the data center, and swap stuff out. It's incrementally scalable. If I actually start, on all the previous solutions I was showing them, those were like generally the most common database scaling solutions. There is very limited write scalability. Because you're only writing to a couple of nodes, depending on your replication factor, you don't have to write to everything at once. You don't have to verify against every single node at once. You can actually scale up your writes by simply the number of nodes that you add. However, you're going to pay for this with a feature with an aspect called eventually consistent. Just because you write to one Cassandra node at one given point does not mean it's going to be immediately readable off of another Cassandra node. This would be particularly disastrous if you're running a shopping website and you write to one node, but you're showing the contents of the shopping cart immediately on the next page by reading the contents of another node. That actually has happened in sort of a traditional master-slave environment where we've actually sent a write to a master. This person added to his shopping cart, and then following page, it's all gone, and they get really upset, asking, "Hey, where'd my stuff go?" What you are paying for, but what you are getting for it is eventually, once it's consistent, you're happy with a few minor inconsistencies. So, case in point, up until 6 weeks ago, I was working at Tivo. So if we're actually going to store our program guide information in an eventually consistent database, and by program guide information, it's sort of like TV Guide. It's that guide you go to on any of your cable provider boxes that says when Everybody Loves Raymond is going to be showing. If you actually see two inconsistent show times for Everybody Loves Raymond, you are probably not going to be particularly upset. You will get upset if they're still inconsistent the closer you get to the show time. But, if you're still about 3 weeks off from the actual show time, you're not going to get so upset if that information is inconsistent. So there actually is data out there that is highly digested by a lot of people, but you can actually get away with it being inconsistent. Now, I'm not saying that Cassandra takes weeks and weeks to make the data consistent. It can actually take up to minutes depending on how big your cluster is. You've got tunable trade-offs between consistency and latency. So who here is familiar with Cassandra in general? Okay, so everybody knows about the CAP model. Minimal administration, I wouldn't say it's minimal administration. It's less administration than a Galera cluster or than an NDB cluster. And there's no single point of failure in the topology. I tended to look at Cassandra because somebody said to me initially, and by the way, I only consider this half true, that Cassandra is really close to MySQL. Operationally, instead of actually typing MySQL at a command prompt, you can just type CQL with all your other arguments such as host, password, whatever, and you can get something that looks functionally like MySQL. After all, the following commands still work: select, insert, update, delete. And everything, and tables still look like tables, and databases still look like databases. But there are a few caveats. A traditional RDBMS treats tables as structured columns, whereas Cassandra treats tables as collections of key value pairs. I know if you're someone who's just simply playing with a simple database and all you're doing is experimenting, it probably won't matter to you. If you're just simply looking for a place to hold your record collection or your baseball stats, you probably won't notice a difference. Where it does make a difference is most of us have actually dealt with huge tables that you need to perform a DDL on, usually an alter. Those alters can take forever to perform. Wait, is it just me or is this not? Is this in and out? Okay. Except that in Cassandra, since everything is treated as families of columns, actually, I'm getting ahead of myself. CQL is not quite SQL. There are still a few differences between SQL and between SQL and CQL. You can't. If you perform any statements that require a where clause, you can't perform it against a field that's not indexed. Which actually, I don't consider that a bad thing because it forces because you would be surprised at how many of your developers are actually writing bad queries all day long, and I think forcing them to actually run their where clauses against indexed fields forces them to think more carefully about their queries. There's no aggregate functions like sum, count, average, etc. But if you really need those, then I would say there are plenty of packages for running your own map reduce functions to organize that on your client end. There's no group by function, and there's no joins. If you actually want to perform a join, you're just going to have to do it on the client side. You're going to have to scan through your result set for whatever foreign key you want to match up against another table, and get that set as well. One of the big things that bit me in the ass was that update statements are equivalent to an insert statement. And what I mean by that is, let's say you're performing an update where with a where clause for a value that doesn't exist. It's actually going to insert it's going to insert that record into the database if it does not exist. I don't know if anyone else has experienced that as well, but there are a few terms that I had to get used to. Instead of calling it a database, I had to start considering it more like a key space. Instead of a table, I had to think of it more like a column family. Instead of a primary key, I had to think of it as a row key. Because in general, you kind of need to think of a Cassandra database as more like a series of key value a series of collective key value pairs rather than a collective series of rows. For most casual users, this is not going to make much of a difference, but one of the things that makes Cassandra a lot different from MySQL is that writing to Cassandra is a lot cheaper resource-wise than MySQL. In fact, actually, because you're thinking in terms of column families, instead of actually thinking of the organizational base as rows, you're supposed to think of it as columns. You can actually add new columns to a table effortlessly. It's just barely a little more expensive than adding rows, but at least now you don't have to wait forever in order to execute a DDL. That's why it's more important to think of it as a column family. And besides, if you actually look at the alternative commands for a lot of the DDL, you kind of have to call it by those names. So, like, instead of show databases, which you would normally do in MySQL, it's more like select from system schema.keyspaces. Instead of create database, it's create keyspace. Instead of use database, it's use keyspace, and so forth. Now, the interesting thing about CAP theorem, well, for those who aren't familiar with CAP theorem, basically it's trade-off availability and partition tolerance. It's a trade-off between consistency, availability, and partition tolerance. Consistency is basically how consistent the data is if you're going to make multiple requests to it. Availability is, well, exactly what it sounds like. And partition tolerance is an interesting one. Partition tolerance refers to what would happen if two partitions or two nodes suddenly lost contact with each other, and yet both of them, or even one of them, was still able to talk to a client on the outside. Now, most people actually kind of treat partition tolerance as being the important one, so they don't actually tune that. They usually tune between consistency and availability. And when they say trade-offs, basically you cannot have all three of these at the same time. Now, one little odd bit about the availability, what I consider the availability of Cassandra, is most of the APIs out there, when you issue a statement to insert or update something, you do not necessarily, unlike the MySQL libraries in PHP or Python or Perl, there's no actual indication as to whether your statement successfully executed or not. You just know it executed, but you don't have any confirmation as to whether it was. Whether it was a permanent, durable write. Most programmers are just simply going to make the assumption that it's permanent. So basically, when you're tuning consistency or availability, one of the things that your Cassandra ring will have is a replication factor. This says how many copies of that particular shard are actually being copied to other shards. In this case, I also sorry to use the shotgun analogy, but I usually refer to it as how many consecutive machines can I take a shotgun to before the cluster stops working. Or at least most clients tend to understand it in that parlance. When you're actually adjusting this, you actually do this when you create the key space, aka the database itself. You can actually just add an extra clause that says replication factor equals some given number, and from that point on, whenever a new table or new data is added, if that number is it will replicate to that many other clusters in the ring, depending on how the partitioner decides it should go. Oh, and of course, I forgot to mention that in the ring, obviously, you can't. There is a partitioner that basically chooses which shard that data is going to go to. It's usually works by hashing the primary key of that table, and says if wherever this hash lines up with, it's going to go to that particular shard. However, whenever you need to add or remove nodes from the table, this partitioner is going to have to rebalance but I'll get to that in a moment. Like I said, when you're trying to set up in a data center, you can actually choose whether your replication should be all within the same data center or some of them actually existing outside of the data center. If you're simply experimenting for yourself, you can do a simple strategy. Just assumes that everything is on the same network, or you can just specify network topology strategy that says that basically says you can just create your own strings that specify a specific data center. Any node that you actually set up outside of that with a different data center string is actually going to replicate to a shard outside of that data center as well. But generally, if you want to keep specific key spaces within a specific data center, this would actually be the place to do it. Now, when I was talking about trying to tune consistency, sometimes you're going to run a query that you actually want to be consistent. One query can be wildly consistent inconsistent from the next. So you can actually add a few quorum levels to enforce this. When you're running a query, you can actually you can add a string that will force a quorum of one of the following. All basically means I want to actually verify I get the same result from all the nodes within the Cassandra cluster, but unfortunately this means that this is the slowest method. You're going to supposedly you're going to wait a long time. I mean, I'm going to say 5 nodes probably has only accounted for about an extra 500 milliseconds and hasn't really been that much of an issue for me. But I'm assuming for those of you who actually run a 20-node cluster spanning 4 different data centers around the planet, you're probably going to wait, another 7 seconds? But very few people actually look for a quorum of all. Each quorum basically means you're only looking for a quorum of a consistent data set, a consistent query result from every single shard within the same data center. Quorum, or excuse me, not every single one. That actually just means a majority within the same. Well, quorum just means majority. So if you're just asking for a quorum result, then your result is only considered valid if a majority of the cluster, if more than 50% of the machines in the cluster agree it's the same result. Local quorum actually means a majority of the machines in the same data center. And you can also set a quorum of 1, 2, or 3, which means I only care if one other machine gives me the same result. And then, of course, there's any, which is exactly what it sounds like, which is pretty much the default. So one of the growing pains is often at what point do I need to add a new node? Node tool is actually a pretty good tool for adding new nodes to your Cassandra cluster. If you actually need to remove nodes or repair them, it's good for that too. More importantly, when you're testing in your environment, Apache does make a Cassandra stress testing tool. It will write 384 byte rows at any number that you specify to your cluster. You can specify how much of a quorum whether you want to stress it by reads, stress it by writes, whether you want how many records you want to write to any given table, how many reads you want to do from one or more nodes. It will actually output your statistics, such as how long it took to do each one, and can do series of tests ramping up, so you can compare number of records that were read or written from anywhere from one to, well, I'll admit I've actually crashed this thing at about 100 million records in a single at 64 simultaneous threads, but I kind of suspect I was on a machine that could not afford to commit 64 simultaneous threads to a test. And if you're actually trying to plan for testing, there's this nice little online tool called Cassandra Planning for Dummies, and apparently it's not letting me go through as a regular link. You know what? This slide is actually going to be available, and you can visit it on your own. So I kind of meant for this to be more like a birds of a feather for people who have not yet dipped their toes into Cassandra. That's pretty much the end of talking about my Cassandra growing pains. If anyone's got any questions, I'm done. And how early am I? I'm about 18 minutes early. Does anyone have any questions or or comments or horror stories or war stories? Well, okay. Thank you.